All right, I think we can start slowly. Hello everyone, this is Olgun Aydin, and today I'm going to be chair for Shiny Demo, first Shiny Demo sessions. And I'm quite excited as a Shiny developer and as also, big fan of R. So the session will follow like that. So I will be inviting speakers, and then every speaker will have 5 minutes. So we will not have questions in this session, so there will be dedicated Q&A session. So if you have any question, you can also join to this dedicated session as well. So maybe let's start. Our first speaker today is going to be Mintu Nath, and he's going to talk about app-based activities for communicating and understanding statistics. Mintu, if you are here, just give us a sign. Hey, Mintu, it's great to see you here.
Hi, Olgun.
Okay, so we are very excited to see your Shiny application. So if you are ready, if you could share your screen, and then I will ask you to turn off your video, and I will be turning off my video as well. So then we will keep going, and there will be 5 minutes slot, and I will be giving some bells, voice, something like this, when just only 1 minute left.
Okay.
And so if there will be something not going well, we will be also communicating with you. Also here we have people from the organization committee as well, and then they will be supporting us in case of any issues. All right, yeah. So have a nice speech.
Great, thanks very much.
All right.
Hi everyone. So I'll be talking about ABACUS, which is stands for app-based activities for communicating and understanding statistics. So it will be mostly from the statistical perspective, means as someone who wants to teach statistics and how some of these subtle and critical components of statistical theories and concept, how we could give it to some of these students who are just learning statistics for the first time. So ABACUS is nothing really novel in that way, because ABACUS is standing on the shoulder of giants, and many of these apps across our community created. What ABACUS really tried to use that some of this excellent work people have created and tried to sort of standardize the framework for a set of statistical tools and use the power of simulation, power of Shiny, and make it as simple as possible so that we can talk about a simple and integrated story. So for example, I can give, sometimes I use the story of obesity in children and use body weight, 10-year-old body weight or 12-year-old body weight, and use that story to give the concept of normal distribution, sampling distribution, t-test, z-test, analysis of variance, sample size calculations, all those different concepts. So I'll give briefly a demonstration of this ABACUS using just one of these modules, the analysis of variance, and hopefully that will give you some of these ideas that we can do using ABACUS. So most of these modules are used based on the frequency-based inference. That means we can, an experiment is an instance of infinite sequence of possible repetition of the same experiment. So some of this intercept includes particularly one important thing that I thought could be quite interesting is to give the user the control about the input value. So the way it helps, it doesn't then anyone from whatever the medical statistics or agriculture or social science, they can use that tool very easily. So that they just have to use the input value according to their own story, and they can integrate it quite seamlessly. The second thing is that in this, it is something about also when the truth is known. So this is something that we know about the true population mean, And then we can show the students how the magic of statistics works, that how the statistical inferential tools are trying to get to know about those population truth. And also all those different other statistical characteristics like sample size, then type 1 error, probability, all those things are integrated, and one can really go through that story, and that all those tools can then seamlessly, they can integrate and can communicate in much better way. So, and also another thing that I tried to utilize that, so that it can also provide some better understanding about the best approach of this descriptive statistics and summary statistics that the students should do. For example, we could show that we can really see how to present a box plot and all those individual observation. And in the context of also, of course, some of these other things that we can do, like sum of squares or mean squares, which again, not many other statistical package can provide. And also, it's more intuitive way of providing the distribution of null hypothesis and those alternative hypotheses. And so mainly the distribution of null hypothesis, our observed test statistics, and how it could change all the statistics because of the sampling by changing those parameter values, and also changing your standard. For example, in this scenario, changing the population mean, changing the standard deviation, or different sample characteristics, or type 1 error, or probability of tails. So that could be quite interesting. And another thing that I use in general the class is just many of these things are also integrated with many activities, so that they can just play with this app and can understand. For example, they can state the null and alternative hypothesis. They can talk about the test statistics, distribution of test statistics under null hypothesis, confidence interval, and also provide the appropriate conclusions. And also lots of different other things like type 1 error, type 2 error, and all those other scenarios they could explore straight away, which otherwise would be really difficult to give any standard example. So this is now...
Sorry to interrupt, so we are out of time. If you could wrap it up in 5 or 10 seconds, that would be great. Thank you.
So just to wrap up that this is a really simple and integrated way of presenting statistical principles and theory for the students who are learning statistics. This is now available in CRAN also, but if you are not used to the R package, you can also use straight away from the web services available on ABACUS. Thank you very much for your attention. Thank you.
Thank you so much, Mintu, for your talk. And so see you in the Q&A session. All right, so our next speaker is going to be Andrea Melloncelli, and the talk will be about Media Shiny, which is marketing mix models builder. I would like to invite Andrea to the stage.
Hi. Hi, Olgun. Hi, everybody.
Hi, Andrea. It's great to see you here.
Thank you.
Okay, so if you could share your screen,
yes.
And then let's be sure that it's seen pretty good, and then we can go ahead. Yes, so we can see your screen at the moment. So stage is yours. So as you probably also heard, I will be giving a doorbell sound. Okay. When 1 minute left, so then if you could start wrapping up when you hear this sound, that would be great. Stage is yours. Have a great speech.
Thank you. Good afternoon. My name is Andrea Melloncelli. Presently, I am a consultant with Valog, which I co-founded in January 2019. And today I'm going to present you Media Shiny, our marketing mix model builder. Marketing mix models are used to understand the effects of the advertising campaigns. Building such models is challenging. First of all, it requires control over the external effects, such as seasonalities, competitor activities, etc. Secondly, it requires to model the decay effect of communication, namely the ad stock effect. I advertise today, and its effect lasts for the next 2 weeks. This timeline represents well these two aspects. The first one is labeled in blue, and it is the effect of each variable that move the sales up and down. For instance, we imagine that a TV campaign creates a peak, and while competitor activity erodes the sales. The second effect is the ad stock, the carryover effect of communication. Here is labeled in violet. The ad stock has the horizontal effect. It prolongs the advertising effects over time, following a decay function. The ad stock effect of each campaign depends on the efficacy of the advertising. So each campaign has its own ad stock value to be estimated. The estimation the estimation of the advertising effect has a meaning only if we control over the factors that can influence sales, such as seasonality, market trends, presence of promotions, changes in price, distribution, etc. These variables sometimes are available and relevant, other times they are not. MediaShiny is a Shiny application that allows you to perform all the steps of marketing mix model. It is designed to serve companies from every field and to allow an interactive building of the final model. Using MediaShiny, you can perform feature selection and transformation, data exploration, pairwise correlation with sales, ad stock control, model selection and building, model evaluation, and finally forecasting. MediaShiny is a package application developed with Golem and modularized with the Shiny module, automatically built and provisioned by Docker image and running in a Shiny proxy instance. Best user experience is provided with drag and drops, and navigation is guided by action buttons. If you want to know more about this kind of application, follow my workshop Saturday morning. Now let's see the app. So build a model. By the upload button, we can load any XLS file and obtain the list of its variables. Then we can create some derived variables. In this case, what we want is the seasonally adjusted version of the sales, which is our dependent variable. Looking at the preview, it is done. Now back to the model builder, we can choose our dependent variable, the time horizon, then we can choose which independent variable to use in the model. Finally, we select media variables, which are independent variables to which we will apply the ad stock effect. We are now observing the correlation between dependent variable in black and variables we have used in colors. This application, MediaShiny, is intended for building the model through subsequent iterations. Try to insert some variables, verify the impact they have on the model, and continue working on until a satisfactory model is obtained. We are building a descriptive model. The goal is explaining how variables contribute to explain sales behavior. As a result, we obtain the effect of TV and radio and digital media and the R-square value of the model. Then below, a table with the coefficient, the comparison between the expected values and the value estimated by the model. The effect table, which breaks down the sales into the fundamental components that we have included in the model, and the effects breakdown plot. This is only one of the several features of this application. Thank you for your attention.
Perfect. Thank you so much. It was on time. Great talk. So then the next speaker is going to be Ottavia M, Epifania, and the speech is going to about scoring the implicit association test has never been easier, DscoreApp. So quite excited to hear this speech. and we are waiting for Ottavia.
So,
Hi.
should I go?
Hi, Ottavia. Welcome.
Hi, thank you.
Welcome. So, stage is yours. If you could test your screen sharing, and then we can start, I guess.
Can you see me? I mean, my screen?
Yes, exactly. It is visible. So, stage is yours. Have a great speech.
Okay.
So just a quick reminder, and you will have 5 minutes, and you will hear this bell sound, bell voice, just one minute left. So if you could just start wrapping it up, and when you hear this sound, that would be great.
Okay,
have a great speech. Bye-bye.
So, can I go?
Yeah.
Okay. Hi, everyone. As you may have heard, I'm Ottavia.
Sorry for the interruption. Just for the sake of the recording, and it's advised to turn off the video during the speech.
Yeah.
If you could also turn off your video, and you should see the buttons on the screen, and the one on the left-hand side will allow you to turn off.
Yeah, but it's covered with everything else. Right. Just 1 second.
Okay. Yeah. Perfect. Perfect now.
Okay. Got you. You got me? Yeah.
Perfect.
Okay. I'm sorry. Okay, now I can start. Okay, I'm Ottavia, as you may have heard, and today I'm going to talk to you about how I made the computation of the implicit association test easier by using a Shiny app. So the implicit association test is a test that is commonly employed in social psychology for implicitly assessing the preference between two contrasted objects by measuring the speed of the performance of the respondents in two contrasting mappings, namely mapping A and mapping B. Both mappings are composed by two blocks, a practice block and a test block, but actually the categorization task is the same. So the IIT effect is given by the difference in the respondent's performance between the two mapping conditions, and it's usually expressed by the D-score. For computing the D-score, we first compute the size effects for both the practice and test blocks by standardizing the difference in the average response times between the two mappings. And then, for computing the actual D-score, we just compute the average between these two quantities. It's not over though, because we have 6 different algorithms, and these algorithms differentiate themselves according to the strategies we use for correcting the error responses and whether we decide to delete or not the trial faster than 400 milliseconds. Of course, there are available options for computing the IIT D-score. We are not the first one doing so, but they all come with some drawbacks because some of them are not open source, and besides, the open source alternatives are not intuitive and easy to use, and on top of that, they do not provide an immediate glimpse of the results, a graphical representation of the results. So I thought that maybe by providing people with a Shiny app that could actually make the computation easier. Here we are. This is the D-score Shiny app in which the users can read the instruction on how to import the data, and they also find a detailed description on all the D-scores that can be computed. They can either decide to use an example dataset that is inside the app to familiarize with its function, or maybe better to browse within their files, upload a CSV file containing the raw data of the IIT, prepare the data, and once the data are ready for the computation, they can just select a D-score algorithm from the drop-down menu, calculate an update, and in a reasonable amount of time, here we are. Okay, here we have the descriptive statistics of the results, the practice, the test, and the D-score, as well as the IIT reliability. We also have an information regarding the number of trials that are above 10,000 milliseconds, as well as an information regarding the number of trials faster than 400 milliseconds, and that can be discarded. But since we selected the D-score without lower treatment, we see that it's not expected for this D-score. But we can also see how the results are changing if we change the D-score algorithm, and we change with an algorithm with the fast trials deletion. So we see that we have 138 trials less that have been deleted, and also the IIT reliability change. It's just a slight change. But let's talk about the graph, that is the most important part. Here we see the D-score of all the participants in our sample, and this graph allows us for investigating the possible outliers, like this point here. We click on the point and we identify the participant 31 as being outside our sample. Or we can also see the cluster in the data, and we can see these participants here, and so on and so forth. Of course, we can change the graphical representation. We can have density distribution to have a better idea of the distribution of our results. And when we are done with the computation, we can download the plot in a PDF format, and we can also download a CSV file, as we can see here, containing the label of the algorithm that we choose. And this CSV file contains all the information that we have to report in the paper when we talk about the implicit association test. So last but not least, this QR code will redirect you to the GitHub repository with the source code of the app, while here you can find all my contacts and information if you want to contact me. And thank you so much for your attention, I guess. Thank you. I'm done, seriously.
Thanks a lot, Ottavia. It was good time management. And thanks a lot for your also speech. It was a very interesting one. All right, so we keep going on. Our next speaker is going to be Riccardo Porreca, and he's going to talk about Hexagon sticker app. And Riccardo, just give us a sign when you will be here.
Okay, here I am. I guess you can hear me well. Let me share my...
Yes, we can hear you well.
Okay, perfect. Yes, very good. Okay, great. So I should know about this.
All right.
Okay, perfect. I get started.
Cool.
Okay, so today I'm going to show you a bit the rTRhexNG, which is a Shiny app we have developed in order to create a sticker for a package called rTRNG. Actually, the app is all you see here, so it isn't anything really fancy in terms of Shiny stuff, but it proved to be very useful, and this is what I'm going to show you. So it was useful not just in designing the sticker, but also we realized at the end of our journey in constructing the sticker that the app could actually be used to showcase what the package does, because the sticker was designed in such a way. So what rTRNG is basically a package for advanced parallel random number generation, and it addresses one of the key limitations of random or traditional random number generators, which is the fact that typically you can generate numbers, random number, or pseudo random numbers to be precise, in a purely sequential way. So just one after another, like in this sequence here. So this is what we typically use in Blazar, but if you would like, for example, to simulate something in parallel or in a distributed manner, the problem is that you might want to split the generation among different workers, and this is not really supported out of the box by traditional generators. So rTRNG and the TRNG library it is based on, it's a C++ library, allows to overcome this limitation in two ways. So the first thing is jumping. So you can basically, with rTRNG, jump ahead an arbitrary number of steps, in this case like 3 steps ahead, and then you can simulate from there without having to generate all the intermediate steps. And the jumps can be really, really far ahead. This is a kind of an obvious technique, and the second one is less obvious but even more powerful. So, for example, if you wanted to, oops, sorry, not this one. If you wanted to, from the jump, say I want to generate just one element per side here, so one element every 9, starting from the 5th, for example. So with rTRNG you can do it. This is called split, and this allows you to generate directly, so without going through all the intermediate steps that you want to skip, the subsequence that you obtain by basically decimating the original full sequence. So this is in a nutshell what rTRNG does, and you can already see the design of the sticker. So we already have a nice T, and the only thing that we are left with is bringing up the rest of the name of the package. And this is what is coming here with the text. So this is in the end the let's say way of using the app to show what the package does. And now let me talk about why it was important to have such a shiny app. Of course, we had kind of a clear idea of what we wanted to have as a general design, but we didn't know the details of this. And imagine if we wanted to redraw by hand this sticker every time we wanted to assess like a different number of elements we want to put in each side, or the number of elements that we want to simulate in this T thing. It would be a nightmare to do it manually. So we ended up writing some R code that does it, and then a nice shiny app around it. The nice thing about this is that, in fact, while implementing these things, we were sort of thinking outside the box, and in the end, it was even easier to think about implementing the precise location of these elements by just thinking polygons, not just a hexagon. So we can very easily decide to go for a different number of polygons, make it round, and most importantly, we can also simulate colors using the actual rTRNG package, which would be drawn randomly and resimulated randomly for this T jump and split thing. So this is pretty much it, and of course, I mean, you can change the colors, but that's trivial. So if you want to know more about rTRNG or the app, feel free to reach out in the Q&A sessions, and I'll be happy to talk about actual, also practical uses of the package itself. Thank you.
Perfect, Riccardo. Thanks a lot for this great speech. It's very, very interesting. All right, so our next speaker is going to be Antoine Logean, and the speech is going to be about how green is your portfolio, tracking carbon dioxide footprint in the insurance sector.
Hi, can you hear me?
Yes, perfectly. Exactly. Great.
Great.
Great to see you here. So if you are ready, you can start with sharing your screen.
Yes. There, here. Okay.
All right.
Good.
Perfect. So you will hear this bell when you will have only 1 minute left. So if you could start wrapping up your speech when you hear the sound, that would be fantastic. So stage is yours. Have a great speech.
Okay, so thank you everybody to present you our Shiny application. So it is about a portfolio, a sustainability portfolio profiler. So and we developed this mainly for the insurance industry. So in fact, calculating the carbon footprint is quite well known in asset management. So investors want to invest in companies that are, let's say, good for the planet. And in fact, now the same happened in the insurance industry. So insurance want also to sell policies or to insure companies that are sustainable. For example, now we don't like much to have thermal coal companies in our portfolio. So the tool is about helping insurance to manage their portfolio of risk. And here, when you think about portfolio of risk, you just have to think about a list of companies. Now, very simply, if I have to really very simply, let's explain the approach, you just have to imagine that you have a list of companies, and then we match these companies with a reference database that allow us to tell you the industry segment of each company, and then by using a predictive model, we can calculate the CO2 emission of each company. Okay, so this is just for the introduction. Then, of course, the app is used by, we'll go back here, used by some person in charge of the portfolio, and the first thing that the person will do is upload his portfolio, which is again a list of companies. So here we write, we generate in fact a random portfolio, because of course we cannot share its confidential data. And here you see we have 11 portfolios, so 11 sets of companies. Overall, we have 1,534 companies, and we have 10 dimensions. So here it's industry, countries. You will see that. Also, we have the coverage, because in fact, in order to be able to predict the CO2, we need, of course, to know the industry. So we need to be able to match the companies. Okay, so this is now for the data, and now, of course, the most important part is the footprint. So here, of course, it's a heat map. So this heat map will tell you exactly, where, in fact, the problem here is. For example, here you see that you have two, in fact, industry segments that are problematic. And so that you can also decide, okay, now I want to reduce my exposure there. Of course, you could also look by country, so we can splice dice in all possible dimensions. And here you will see that, okay, so it's probably United States and France and Hungary are really two countries that are not so good. And you can also, of course, target the portfolio. So basically, this heat map can be used by the portfolio owner to really optimize or the CO2 footprint of his portfolio. And I think my time is up, right?
Yes, exactly.
God, 5 minutes is so fast.
Yeah, time flies. I agree. All right, so thanks a lot for your speech. It was quite an interesting one. And I would like to invite Emanuele, and then it will be the last speech in this session. So Emanuele, please give us a sign when you will be here.
Can you hear me?
Perfectly, we can hear you. Let's hope this time everything will work.
So I switched actually from Firefox to Chrome. I hope it
All right.
guarantees a more stable connection.
Perfect. So just I will repeat your talk, and he's going to talk about a data scientist friendly adding for RStudio. So stage is yours.
So can you see my screen?
Yes, it's
okay.
visible. Yeah.
Great, thank you.
So if we could also turn off our videos, that would be great.
Yeah, sorry for that.
No problem. Okay, have a great speech.
Okay, so in the last few years in Extreme, we had the opportunity to address very interesting projects about time series forecasting. Time series forecasting is a very interesting problem, and as each problem in data science, a first step is, of course, data exploration. Project after project, we realized that some of the steps about data exploration for time series forecasting are actually almost every time the same. You plot the target series, you plot all the related series, you try to understand what's going on with the autocorrelation function, cross-correlation, you perform a little bit of Fourier analysis, just to tell the most basic kind of analysis you do in the data exploration phase. So we decided to try and create something to ease this step of the process. We thought about a library. There are plenty of them out there which can help with time series visualization and time series analysis. But actually, RStudio provided us with a much more effective tool, that is addins. Addins were introduced not a long time ago, a couple of years, if I remember correctly, and they are amazing because they allow you to put Shiny applications directly into your IDE. So you can transfer the power of analysis directly into the tool every data scientist uses for its daily operations. So you have a great power to speed up all the tasks. So let's go into the action. How does tsviz work? It is a package. It is, of course, on CRAN, and the source code is available on GitHub. You can import the library, and then there is a dataset, this crypto price, which contains the close price of Litecoin, Bitcoin, and Ethereum 1,200 days. You can run the addin with this command, simple function, and this is what happens. So you get these mini UI Shiny applications, which displays your dataset. That's not very interesting. The interesting part is that it automatically detects all the datasets in your workspace, which are possible time series. How does it do that? Well, it looks for datasets for data frames, sorry, with one column of type date and at least one column of type numeric. So here we have line charts we can compare the time series. Of course, we can compare Litecoin and Bitcoin, and we can see that basically the trend is very similar. We can normalize the time series to see it better. We can make scatter plots, of course, normalized or not. And another thing we can do is have a look to the autocorrelation and partial autocorrelation functions. So here we can adjust the legs and perform every other operation. So to wrap it up, as the bell has already rung, this is, I think, a very powerful way to put new tools in the hand of data scientists in a very simple and effective way. You can check out our Medium post describing the addin and how it is built. And of course, you can check out the code on GitHub. It is open source, publicly available. And of course, if you want to contribute with pull requests, you're very welcome. Thank you very much.
Perfect, Emanuele. I'm very happy that it went very well, and thanks a lot for the great speech. And also, I would like to thank all the speakers who gave speech in this session. Thanks a lot for your great talks, and it was extremely interesting. And thanks a lot for all of you to join this session. So you can jump into the Q&A session. Right now it's happening. And so see you around. Have a great day.